probability with the tree diagrams. This one particularly said the exercise is taking 2 cards out of a pack. What is the probability of taking 2 heads if I don't replace the first one? Very important. With replacement, without replacement. There's 2 variances. Now I won't do that in a test with you. I won't ask you to do both of them, but this is now a good exercise. Whichever one I ask you in the test, you have to know what to do. So if I say there is replacement, it means I take one card, look at it, and I see it's a 3 of diamonds, and I put it back. I take another one, and I see whatever it is. Now the probability of having a heads and a heart and another heart, not heads, what am I talking about? Is it's either going to be, now we spoke about this in general just when I gave you the homework. Probability of getting hearts. First of all, how many heart cards are there in a pack? 13. Alright, because there's 13 of each of the 4 houses, they sometimes call it. So for hearts, there's 13. And for not hearts, it's the rest. 39 out of the 52 cards that's in front of me. Now if I take the card and I look at it and I put it back again, what happens with this side? Nothing. It stays exactly the same. Oh, I wrote it wrong. Right. So, that if I asked you for the probability of having heart and another heart, there's only one option, and it's those 2 tree branches. 13 out of 52 times with 13 out of 52. And the answer, please, is?
One over 16.
Thank you. Okay. So, if it's not replaced, I take out a card and I look at it and I put it on one side, and I then take another card. The difference is, it would still be 13 out of 52 and 39 out of 52 for being a hard card or not a hard card. But then, the second card that I take, there is only still left 51. Right? If this is the scenario, I took a heart card, then there's not 13 anymore, there's 12. And if it was a heart card, the not hearts are still 39. If I didn't take a heart card, there are still 13 left out of the 51, and there's 38 of the not heart cards left. Are you with me, guys? Yes. And then again, don't forget to write your outcome. So the probability of that same question has now changed because of the not replacing. That it would be on the heart, 13 out of 52 times 12 out of 51. Now think about it. Would you have been able to think this out if you practice a little bit? That the probability of getting a heart card is 13 out of 52. And then for the next one to get another heart would have to be 12 out of the 51 without doing the tree diagram. Could I have done it without the tree diagram? Definitely. Something wrong?
No, it's supposed to be 52.
Oh, thank you. What did I write? 59. Thank you. And this answer?
1 over 17.
Okay, so the chances of getting 2 hearts without replacement, which is the highest probability? 1 out of 16 or 1 out of 17? Oh, you agreed with that. I don't know why they would ask that, but anyway. Okay, the other question I gave you for homework was number I on page 361 that said, some famous weather guys looked at the weather and they say, somehow they worked it out, that if it rains on a day, the chances of it raining the next day is 40%. If it doesn't rain on a day, the chances of it raining the next day is 10%. How they got to that is not my business. Okay, so if it rains today, the chances of it raining tomorrow is 40%. If it doesn't rain today, the chances of it raining tomorrow is 10%. That's the statistics that they give me. So, they want to know, if it did rain on Monday, what are the chances of it raining on Wednesday? That was the question. So first of all, the first idea is, okay, there's Monday, there's Tuesday, there's Wednesday. There's not three scenarios. The first thing is that it did rain on Monday. So if it did rain on Monday, what's going to happen on Tuesday? Chances of rain is 40%. Meaning that this would be 60% of not raining. Are you with me? Because it did rain on Monday. There's no other options there. It did rain, so therefore. But now whether it rained or not, there's other options for Wednesday. If it rained on Tuesday, it did rain, then it's still going to be 40%. If it did not rain, the chances of rain is 10%. Now let's complete the whole tree diagram, because remember all the branches must be completed. So this will still be 60, and this will still be 90. Now what was the question? What is the probability of it raining on Wednesday? So where do I look? Raining on Wednesday is this one, or this one. Do you agree?
Yes.
This is raining on Wednesday, and this one. So it's got to be these outcomes here. Or if I want to say, first of all, probability of raining on Wednesday is that it rained on Tuesday and rained on Wednesday. Or it could have not rained on, because we don't know if it's going to rain on Tuesday, there's a probability. If it didn't rain on Tuesday, what's the chances that it will rain on Wednesday? Are you figuring out that? So again, with the and the or, and the and. But if you didn't write that, it's perfect that you just knew it was that times that, and that times that. So 40% times with 40%, and 60% times with 10%. Now you can write it that way, no problem with that. I would prefer actually if you wrote 40 over 100, 60 over 100, and 10 over 100, that you just don't tell me 40 times 40 is 1,600%. Okay, and the answer please is?
11 over 50.
And 11 over 50 means what? What was the question? What did they ask you for the chances, or did they ask the percentage? What did they ask? The percentage. So do I leave it this way?
No.
If they don't give me any options and I can choose, can you leave it this way? Yep. Can you leave it in decimals? Yep. Can you leave it in percentage? Yep. But this one asks for percentage. So you had to take this one to 0.22. If you wanted to write it, it's fine. But then you have to say it's 22%. Or you can directly go to percentage. Doesn't matter. You don't have to show me all of them. But please answer the question. Right. Okay. In the prelim exams just now, in September 23, they asked these probability questions just so that you can see what you've done now is done. And they're going to test you on it all the time. We're not going to redo it at some stage. Maybe by accident for some revision somewhere. So the question started off like this with a Venn diagram and said, machine A and machine B are two different coin pressing machines that operate at the same time. The probability that machine A only presses a 5 rand coin is X, and the probability of B only presses a 5 rand coin is 0.3. So this is all about pressing 5 rand coins. And the probability that both machines press 5 rand coins at the same time, so they're pressing other stuff as well, but this is about pressing the 5 rand coins, is calculated there. So obviously there's an overlapping, and that's what was given as 0.1. First question, if A and B are independent events, what is the rule I'm testing? Probability of independence? Events? Rule. The and is the product. Now guys, if you don't know that, you're going to get 0 for the sum. That's it. Can't go anywhere with it. So you have to know this. Now, out of the Venn diagram, what's and? 0.1. What is the probability of A? X plus 0.1. Remember, A is everything inside there. So actually over here should be X plus 0.1. We normally write it that way, but now we're still trying to find X, so it's not a good idea. But B is okay. Would be 0, 4, and that's what I'm going to have over here, 0, 4. Multiplication. What do I have to do here? Solve for x. How? Do you want to divide by the 0, 4? That's an option. Please let's do that. Divide 0, 4 into this side. What is it? Okay, it's 1 over 4. Okay, and then to get x alone, minus with 1. So x is 0, 15, and you've got 4 marks for a matric final prelim exam. Is it what you've done?
Yes.
Okay. Second part of the question, same question, says determine the probability that exactly one of the machine. Oh no, sorry, I'm not quite finished. The first question said find the values of x and y. And even if they only asked for x, I still have to get the y to be able to get. Just no, that wouldn't be, but they did ask for y as well. How would I find the y part then? Substitute x into what? All of them equal to?
1.
So 0, 15 plus 0, 1 plus 0, 3 plus y must equal 1. That's the fact. And then you're just going to get your y answer for the second mark. Oh, it was just 1 mark, sorry. Just 1 mark. For knowing that you've got to do that. What's the answer, please? 0, comma? Okay. One question done. This one was 4 marks. So what would it have been? Definitely for the rule. Not for just writing it, but knowing that you must use it. For the left side, the right side, working out the x. Okay. Question number 11.1.2. This was 1.1 and 1.2. This is 11.2. They say, Wilson takes a driver's test. Probability that he will succeed on his first attempt is 3 out of 7 because they've got the statistics there. For each attempt that he redoes the test, the probability of passing increases to 3 over 5. But in other words, all the time then it's going to be 3 over 5. Only the first time the probability of passing is 3 out of 7. Then the next attempt changes to 3 out of 5 and 3 out of 5. And hopefully not 3 out of 5, 3 out of 5 all the time until 10 times, hopefully. Are you getting the picture? What is the probability that he will succeed after 2 attempts? What are you thinking? Tree diagram. Did they say tree diagram? No, but it's a good idea. So first circumstance is you will either pass or you will fail. And what's the probability of a first pass? First attempt pass? 3 out of 7 making this? 4 out of 7. That's his first test. Now, does this make any sense?
Yes.
Why not? He passed. Why does he want to take the test again? If he passed on his first attempt, does this make sense? Are you with me here? I won't deduct marks if you do that, but what are you doing it for the fun of it? I've got my license, why would I do it again? If you fail, you're going to have to either do it again and pass or fail. And again, pass, yippee, I'm done. But for fail, you're going to pass or fail again, etc., etc. Are you following?
Yes.
Because it's logical, if you pass, then it's done, hopefully. First attempt is second attempt, etc. All agreed with that one. But now the question says, if he does fail, and he redoes it the second time, the probability increases of passing to 3 over 5. So this is 2 over 5. And the next stays 3 over 5, 2 over 5, because that's what they said. Okay, where they get to their data, I don't know. First question says, what is the probability that he will succeed after 2 attempts? that means it's got to be a fail and a pass. That's very important. That you won't write pass and pass. Because that's not logical. So for a fail and a pass, what's going to happen? You're going to have fail, pass. 4 over 7 times 3 over 5. And an answer, please. 12 over 35. Okay, now I don't have lots of space. I'm going to squish it in here. The last question for this probability was, determine the probability that he will succeed after 3 attempts, Shane. So that would mean probability of fail, and then to pass. It helps you to write it down. It's not worth any marks, but it helps you to write it down. So then, let's not think about it. Probability of failing is 4 over 7, right? Not 3 out of 7, the one that they gave me, because that's the passing. For the failing the second time, it's 2 out of 5. And then for passing the third time, it's 3 out of 5. Now, lots of kids did want to try in my grade 12 class to do it this way without a tree diagram. Then they wanted to put the 3 over 7 here and the 2 over 5 there because they get confused when is it pass, when it isn't fail. So rather do the tree diagram. It takes you a little bit of time, but you can see what's happening. Final answer?
24 over 1.
Over?
175.
175. And that is that for probability.